Hi, today we are going to study greedy algorithms and we are going to solve activity selection problem. Before starting that, let's first see what is an optimization problem. An optimization problem is the problem of finding the best solution from all feasible solutions. So, in these problems, you have some objective or goal of the problem that should either be minimized or maximized. So there are many possible solutions, but the best solution is the one that minimizes or maximizes the objective of the problem. So uh, a feasible solution is a solution that satisfies the constraints of a given problem. There can be many feasible solutions. So after feasible solution, we have optimal solution. So out of all the feasible solutions, the one that gives the maximum or the minimum value, depending upon the objective of the optimization problem, is the optimal solution. So let's see what optimal and feasible solutions are through an example. Let's say you want to travel from Lahore to Karachi in less than 15 hours. Now, in this problem, less than 15 hours is your constraint. Um okay, and then to go from Lahore to Karachi, you have following options. You can go by foot, that would take you 1 month, or you can go by a motorbike, that would take 1 week, and let's say going by a car takes 3 days. Um, then going by bus is 1 day, train 12 hours, and plane takes 1.5 hours. Now, you have a constraint of less than 15 hours. Now, of all the possible options, option number 5 and 6 are the ones that satisfy this given constraint. So according to the constraint, the feasible solutions are options 5 and 6. So you can see that there are more than one feasible solutions for this problem. How can we convert this to a maximization optimization problem? Let's say you want to go from Lahore to Karachi in less than 15 hours, but in the minimum cost possible. Now it has become a minimization problem where you have to minimize the cost. Now, you have two feasible solutions. You can either go by train or by plane, but which one would cost the minimum? Option 5. So, option 5 is your optimal solution. Okay, let's now see what greedy algorithms are. So, greedy algorithm is a design approach to solve optimization problems. Now you know what an optimization problem is. Okay, so how do greedy algorithms solve an optimization problem? Uh, Greedy algorithms always make the choice that looks best at the moment. While solving the problem, it makes an assumption that a locally optimum choice will lead to a globally optimum solution. So, what it does is at every moment or at every step, it makes a choice which is the local optimum. And it hopes that choosing a local optimum at every step or instance would lead to global optimum solution at the end. We've already studied divide and conquer and dynamic programming design paradigms. Greedy algorithms is the third and last design paradigm that we are going to study in this course. So let's first see a small comparison between greedy algorithms and divide and conquer. So it is easier to propose a greedy algorithm than to propose a divide and conquer solution for a problem. Um, you'll see it in the rest of the lecture why it is so. Um, Now, as it is easier to propose a greedy algorithm solution, it is also easier to do the runtime analysis or the time complexity analysis of the greedy algorithm. But there is a catch. It's harder to prove the correctness of a greedy algorithm. So it takes more effort to come up with a divide and conquer algorithm, but it is usually correct. On the other hand, you can come up with multiple greedy algorithms for a problem, but most of them would not be correct. Let's now see a small comparison between greedy algorithms and dynamic programming. So, as you already know, in dynamic programming, we try all possible solutions and choose the best one. And then in dynamic programming, we make a sequence of decisions. So we make a different decision at every step. While in greedy algorithms, we always make the same decision, that is, the greedy choice at every step. Also, in dynamic programming, we keep looking back at the previous solutions, while we do not do that in greedy algorithms. uh, then there's another difference. So in dynamic programming, there's always a guarantee that you will get an optimal solution, because you're looking at all the possible solutions and you choose the best solution out of all those possible solutions. But in case of greedy algorithms, you do not look at all possible solutions. You just make the a greedy choice at every step, hoping that is, you choose the local optimum at every step and hope that it would lead to the global optimum, which is not always the case. So let's see the first example of greedy algorithms. So the problem is minimum coin change problem. To understand this problem, consider that you have a value or an amount, let's say 100 rupees, and a set of coins. Now, you want to give those 100 rupees in change to someone, but using the minimum number of coins out of this set of coins. So let's say you have a value of rupees 100, and these are the coins that are available: 5 rupees, 10 rupees, 20 rupees, and 25 rupees. So now, how can you find possible solutions? So if you use only the coins of value 5, you'll need to use 20 coins. So 5 into 20 is equal to 100. So you'll give the change in 20 coins. You can also use a combination. Let's say you use 10 coins of value 5 and then 5 coins of value 10. That way you can give 15 uh, that way you can use 15 coins to give the change of rupees 100. So you can see that by thinking a little harder, you can reduce the number of coins. Then you can also use coins of value 10, and you'll need to give 10 coins. So 10 coins of value 10 each. But you also have a coin of rupees 24, 25. So you can use that as well. And if you use 4 of those coins, that gives the value of 100. So these are all the possible solutions, but this one is the optimal solution, because this solution uses minimum number of coins. So how can we write an algorithm for this minimum coin change problem? So the first step would be to sort the list of coins in descending order. Now start from I is equal to 0. Now this I points at the start of the list of coins, which is sorted in descending order. Now take the largest coin, which is now at the start of the list. So take coin I as much as possible. If you have found your solution, then you return. Otherwise, you follow step 3 with the next coin. So let's see how this solution works. Now you have a value of rupees 100, and this is the list of coins sorted in descending order. So you start with I is equal to 0. I is equal to 0 points to 25. So you take the first coin as many times as possible, and now if you take 4 coins of rupees 25, you get rupees 100. So you return at this point. So total coins that are used are 4. Now let's say you have a value of rupees 70. So you start your algorithm as usual. You start with I is equal to 0, I is equal to 0 0.225. So you take two coins and that would make it 50. Now if you take this coin the third time, that would exceed the given value, which is 70. So you move on to the next coin, which is 20. So you add 20 and you see that uh, now your change is complete. So you return this solution. Now three coins are needed, two of value 25 and one of value 20. So as you have seen, you're always picking the local maximum, local optimum in this case, the maximum value coin, and you hope that it would lead to the global optimum at the end. So this is called the greedy approach. But it might not always work. So let's say you have coins of this value, uh, coin of value 1, 3, 4, and your value that you want to provide the change for is rupees 6. Now if you apply the same greedy solution that you applied on the previous example, it would first sort this list of coins in descending order. That would give you 4, 3, 1. So you start from first uh, the first element of this coins list, which is 4, I is equal to 0. You will take the first coin 4, and then you cannot take another 4 coin because it will exceed the value, which is 6 in this case. So you move on to the next coin, which is 3. You cannot even use that because that would also exceed the value. So you move to the third coin, which is 1, and you take 2 coins of value 1, and that would give you the solution of 3 coins. But you can see that the best solution is to use 3 uh, 2 coins of value 3. So it might not always work. So it might not always work for all values of this coin.